So welcome back to the video. Previously we were discussing the properties of matrix determinants. So let's continue where we left off with the remaining properties of the set determinants. So last time we covered till property number 8, and so last time we covered if a row or column is multiplied by a number k and then added to another row or column, the determinism is unchanged. So this time we'll be covering property number 9, which is sum of products of a row slash column with cofactor of any other row or column columns is 0. So what does it mean? So basically I will show all these examples to all this in the same example matrix. We will do it practically, so you don't have to worry about it right now. So let's continue. Property number 10 says that determinant of matrix A will always be equal to determinant of matrix A's transpose. This is property number 10. Property number 11. 11 states that determinant of the end result of a matrix multiplication. So basically if we multiply two matrices together A and B, then the determinant of such a matrix can be written as determinant of A times determinant of matrix B. Property number 12. In a similar fashion, if we have multiplied A matrix to itself n number of times, again we are only talking about square matrices here, then this will be equivalent to determinant of A whole power n. Now if you recall, we discussed upper and lower triangular matrices. So in the case of an upper or lower triangular matrix, for a triangular matrix, the determinant is the product of principal diagonal element. Simple diagonal elements. So these are the properties of determinant of a matrix. Now let's one by one check these properties by looking back at our example matrix. So let's see. So this was our example matrix, right? So let's delete this for now because we are checking the properties. So our first property said if each element in a row or column was 0, then you will get det 0. So det determinant of A would become 0. Now this is very easy to see because like if I convert, let's say with this 1 to 0 and this 2 to 0, So let's do this. And expand along this line, you will get like z. Over here you will get 0 into minus 16 plus 0 into minus 10 plus 0 into minus 19. Over here you'll get, wait a second, yeah, this one. You will get 0 into minus 16 plus 0 into minus 10 plus 0 into 19, and you'll get 0. Same case will be applicable if you do it along any row or column, assuming all the elements in that row or column are 0. Same logic can be applied because you can expand determinant along any row or any column. Now, property number 2 says that if we interchange any two rows or columns, so if we interchange any two rows or any two columns, we will get a different determinant. So just to make it simple, we will interchange first row with third row. So let's verify property number 2 by exchanging row 1 with row 3, and let's calculate the determinant in this case. 4 into minus 1 into minus 2 minus 0 plus minus 1 times 5 times 3 into minus 2 minus 2 plus 6 times 0 minus minus 1. So first term becomes 4 into 2 plus second terms becomes minus 5 into minus 6 minus 2 minus 8, and third term becomes plus 6. Now if we add this all together, we'll get 8 plus 40 plus 6, which is equal to 54. Exactly the opposite of the original determinant. As you can see over here, I didn't erase the determinant calculations from the first bit. Minus 54 and 54. This is the confirmation of property number 2. Now let's verify property number 3, which says that if each element is multiplied by number k, then the new determinant becomes k times the old determinant. So let's erase all this. Yay. Let's just erase all this. Now let's multiply our first row with k. I'm doing multiplication along the first row because then it just does not affect the cofactors of that row. You can do it along third row as well. Then you can take cofactors of the third row, which will be the cofactors from other rows. They will not be affected. But for the sake of ease, I am doing it along the first row. So our first row, let's say in our case, let's say I multiply it with, let's pick a good number. Let's take 7. So our first row becomes 7, 0, and minus 14. This row remains the same as 3, minus 1, 2, 4, 5, 6. So the k in our case is 7. So now If we take the determinant of this, because we have only modified first row, so the cofactors of this row are not affected, so it becomes 7 times minus 16 plus 0 times minus 10 plus minus 14 times 19. So if I do a quick calculation, the sum is minus 378, which is exactly equal to 7 times minus 54. So if you remember, minus 54 was our original determinant, equal to 7 times det A equals to k times det A. This is property number 3 verified. Now here's the thing. If we repeat this property for every other matrix, so like we can, so if we multiply it over here, so we can write it k det A, k det A, k det A. If we do this to the whole matrix, it becomes k cubed det A. So for this one, I will be using an online matrix calculator to show it to you real quick. In our original case, we had matrix 1 0 2, 3 minus 1 2, and all. So 1 0 2, sorry, this was minus 2, 3 minus 1 2, 4, 5, and 6. So if we take the determinant of this, we get minus 54. Now let's multiply everything by 3. So 3 0 minus 6, 9 minus 3, 6, 12, 15, and 18, and we find the determinant of that, we get minus 1458. And so if we do that, 1458 divided by 54, 27, which is our case, it is 3 cubed. So here it is with the same example matrix that we used whenever k was set to 3. Now if two rows or columns are same, that was the property number 5, then det A becomes 0. That was the property. So this is actually very easy to prove. So let's say our first row is A1, A2, A3, B1, B2, B3, C1, C2, C3. Now let's, just a moment, we'll delete row 3 and replace it with B1, B2, B3. right? So now let's expand it along row 1. A1 into cofactor of row 1, which will be B2 B3 B2 B3 minus B2 B3 minus A2 into B1 B3 minus B1 B3 plus A3 into B1 B2 minus B1 B2. So it will be A1 into 0 plus A2 into 0 plus A3 into 0. Now in a similar vein, we can prove this property if we have this scenario, which was our property number 6. If two rows are in the same ratio to each other, or two columns are in the same ratio to each other. Now we saw the scalar property, where if one row was multiplied with a scalar, then our det becomes the k times that number, right? So this thing can be written as k times determinant of a1, a2, a3, b1, b2, b3, and b1, b2, b3. But we just now showed that this matrix's det was 0. So this becomes k times 0 equals 0. So this will be all for this video. In the next part, we will cover the remaining properties with the same example to make sure that we are able to see all these properties in action.